We're going to use all the knowledge that we have gathered from our quadratic unit now to apply that into a few of these problems here that we have. So we're going to start out, make sure that we read those directions using that knowledge. We need to be sure that in our answer we include the appropriate unit as well as round to the nearest hundredth if necessary. Hundredth is 2 decimal places. So with this first question, it says there's a small pumpkin launched from a catapult resting on a platform at an initial velocity of 17 feet per second. Here's the equation. H is representing the height, T is representing the seconds. How far off the ground is the platform? So sometimes it helps just to draw a little picture where we have our T here and our H here, time and height. We have a pumpkin on a platform. It gets launched and it's going to come down and hit the ground. So the question is, how far off the ground is the platform or the pumpkin starting out? So here is where it's sitting on the platform. So at 0 time, this pumpkin is sitting at its initial height off of the ground. And so what we're looking for here, if you notice, is where this pumpkin is sitting on the y-axis, or the h-axis in this case. So we're looking for a y-intercept here. Right, so in order to find that, I know that the x value has to be 0. There's no time here. It's just the height that I'm looking for. So I'm going to take my equation, h is equal to negative 16. I'm going to plug in 0 for t, and I'm going to solve. Simplify here. So 0 squared is 0. 0 times negative 16 is 0. 17 times 0 is 0. Added together to 10, and if I simplify, I get 10. So the question is, how far off the ground is the platform? Well, it is 10, and we need to find a unit. So here we're talking about feet and second. So the unit that would go with the height would be feet. All right, second question. Fireworks are shot from the ground at an initial velocity of 100 feet per second. Here's the equation. It represents the height y and the time x in seconds. And the question is, how far off the ground are the fireworks at 1.2 seconds? So again, we have our x here, our time, and our y here, which is our height. They're going to be shot from the ground. They're going to come up, and then what's left, the debris, will come back down to the ground. And so the question is, at 1.2 seconds, how high are these off the ground? So here's the x value. What's the y value that coordinates with that? So I have an equation. All that I need to know is one of these two values, and I'm looking for y, and I have x. So I'm going to plug in the value of x that I'm looking into the equation so that I can find the y that I'm looking for. And my calculator will do these calculations for me very easily. So I'm going to use that tool that I have, and I'm going to plug it in directly to the calculator just like it is on my paper. And I get that y is equal to 96.96. And I'm supposed to round to the hundredths if I need to, and I need to find a unit here. So it's the fireworks are supposed to be 96.96 some unit off the ground. And so I have to again look for units here. And I have feet and second. Since I'm talking about a distance or a height, I'm going to go with feet here. All right, looking at number 3 on this question, we have a basketball shot from a height of 4 feet off the ground at an initial velocity of 9 feet per second. Here's the equation representing h represents the height, t represents the seconds. And it's asking how long would it take the basketball to reach its maximum height. So as soon as we see that word maximum, we should automatically be thinking about vertex. And so the vertex, remember, is going to be your x, y, and in this case, our time and our height. And so the question is asking how long would it take. So I specifically want to know the time from the vertex, not necessarily the height. So if you remember, we always start out by finding the axis of symmetry when we're looking for the vertex. So I'm going to go ahead and start that process of looking for that. So it's going to be a negative b value divided by 2a. We have a 9 for our b value here, and a is a negative 16. So I can simplify this to get negative 9 divided by negative 32. When I work that out, I get 0.2 0.8125 with my calculator. I have I have 0.28125. And so this is going to be the time, or the x value, the axis of symmetry. And if you remember the axis of symmetry, that x value, that independent variable, is the same for the axis of symmetry as it is for the vertex. So I don't even have to look for the h at this point, or that y in dependent variable. I'm only going to be looking for this independent variable, that t value. And so in this case, I have already found my answer. I do need to round, so here I'm going to keep that as a 0.28. And since I'm talking about the time, I have feet and seconds, so I'm going to call that seconds. All right, and then the final question, we have a penny being dropped from a 6-story window and an apple dropped from a 12-story window. We have two equations there that represent those, and then are asking which item is going to remain in the air longer, and for how much longer will it be in the air. So if we think about this, we have two items being thrown, and then they're going to come and hit the ground. So the question is, how long are they going to be in the air? Which one in the air is in there longer, and what's the difference between them? So we need to know the time that lapses from the time it leaves the window to the time it lands on the ground. So we need to know what the time here is. So we're looking for an x-intercept on these. Okay, we're going to be looking for that positive x-intercept. So I need to go ahead and use my quadratic formula, plug these in, and find those x-intercepts. So first off, we have the penny. So we have x is equal to negative 0 plus or minus the square root of 0 squared minus 4 times negative 16 times 75 divided by 2 times negative 16. All right, and so this does simplify. Under my radical symbol here, I have a 0 squared minus 4 times negative 16 times 75. It's a 4,800. This 0 is going to kind of simplify. We'll have a plus or a minus the square root of 4,800 divided by negative 32. And so I can kind of do the rest of this calculation on my calculator. There'll be a positive answer and there will be a negative answer, and they're going to be the same number. So I can do the square root of 4,800 divided by negative 32. That's my negative answer. And I can also do the negative square root of 4,800 divided by the negative 32. And that's going to give me the positive answer. So I have, I'm going to go with the positive answer here because of the amount of time. And so it's 2.17 is how that rounds. We're going to go ahead and round it to the second, or the 2 decimal places. And then now I'm going to do the same thing for the apple. So on this one, I'm going to have x is equal to negative 0 plus or minus the square root of 0 squared minus 4 times negative 16 times 150. We're going to divide that by 2 times negative 16. And I'm going to simplify that again. This time we're going to have 0 squared minus 4 times negative 16 times 150. And I get 9,600 under that radical symbol. And so that's what we're going to use to simplify here. So I end up with a square root of 9,600 divided by negative 32. That's going to give me a negative time. And then I also have the negative square root of 9,600 divided by negative 32. And that's going to give me the positive time. And so I'm going to go ahead and round that, and it rounds to about 3.06. All right, so the question was, which item will remain in the air longer? So this item hits the ground at 2.17 seconds. This item hits the ground at 3.06 seconds. So as far as which one is in the air longer, this one takes longer to get to the ground. So this is the apple. So apple is part of that answer. Okay, the second part of the question is, for how much longer is it in the air? Well, I need to know the difference between these two. So 3.06 minus 2.17 seconds. So 3.06 minus 2.17 seconds is a difference of 0.89 seconds. So the apple is in the air longer for a total of 0.89 seconds longer. And so really it's just important as we go through these practice problems that you are carefully reading the question. Sometimes drawing a picture helps just so that you can kind of see what we're looking for. Make sure that you use those units. It's important that you use those in your final answers. And just be very careful. Read the questions carefully. Draw a picture. Do whatever you need to do. Use your notes there to help you kind of visualize what you're looking for and what that means in terms of an actual quadratic.